Okay. So this concrete, what is this concrete and what is the advantages of this material? It's like it's a rock-like man-made material. Okay. So what it comprises of? The ingredients are going to be Portland or cement. Cement is nothing but a binding material, and the word Portland is appended to cement because initially when the cement was discovered, it resembled some stone in Portland in England. So the name Portland is coming from there. So important ingredients are cement, binding material, and what it actually binds. It binds coarse aggregate, fine aggregate, and water is for chemical reaction. Okay, chemical reaction that happens to help hardening of this binding material. And this, what is the idea of this coarse aggregate and fine aggregate? The core fine when you take a glass or a beaker and try to fill it with coarse aggregate, some gaps will be left, and those gaps will be occupied by the fine aggregate, and the gaps in between the fine aggregate will be occupied by the cement. Okay, and water helps to have the chemical reaction taking place finally, which leads it to a hardened material, like looking like a rock-like material. Okay, so that's why the advantage of this concrete is we can make any kind of shape or anything like that. Okay, and in addition, we may also have admixtures. Admixtures basically to control the properties of the hardened concrete as well as fresh concrete. What I mean is when the concrete is fresh or green, it should allow us some time so that we can place it and other things. So we can have a control on its setting time and other things. And also what I mean by the properties of hardened concrete is if you want the hardening to take place early, then also some admixtures, there is a specific code for this. We'll see in detail later in the later lectures. What are these admixtures? At least few of them. Okay. And now, what is this concrete? What makes it unique? It is a versatile material, and it is easily moldable, and it is flexible, that is pliable when mixed, and it is strong and durable, and also it's not going to rust or rot. Rusting is like a common phenomenon for all these kind of ferrous kind of material like steel and other things, and rotting is for wooden kind of material. It's not going to have those kind of problems, and it's not if the finishing is good, it's not going to require any special coating or anything like that. Okay, and also it resists fire. These are some of the properties which is like advantageous for us to use it as a construction material. And these are some of the structures. Professor Amlan yesterday showed you some more structures and other things. So now let's look at the details of how this concrete is going to be made in a ready mix plant. You must have seen some trucks carrying concrete. So this gives you overall picture about this various process and various components that are going to be there in a ready mix concrete plant. Okay, and at the end I will show you a video as well. So you can see here, the first one is aggregate delivery. Aggregate delivery is going to take place here. Aggregate is going to be supplied through some trucks, and it's going to be delivered here. And aggregate receiving hopper, its aggregate is going to be conveyed, and then this is the hopper. And then aggregate storage is here, C, and conveyor belt from this hopper to this finally into this mixture. This conveyor belt is going to carry the aggregate, and then before that if it is all these ready mix plants are going to be computer controlled, and what should be the aggregate that we need to mix, fine aggregate, coarse aggregate, all those things will be like the computer control, usually will be programmed. So here a weighing machine is there. This weigh, it's going to weigh the aggregate that is going into the mixture, weigh hopper. And G is nothing but your cement delivery. So now this is about aggregate, and then next one is cement delivery. Cement delivery, this is the truck for which delivers cement, and then cement is going to be stored in this material E. These are some storage like bunkers for this cement, and then this aggregate and this cement, okay, and through this after going through this weighing process, it's going to go into this mixture, and if required we need to use some admixtures. Those admixtures also will be added into the mixture, and water is coming from here, N. And sometimes we may make use of, you see all these green ratings and other things, we can make use of recycled water. And recycled water is K. K is recycled water. Usually what happens, this ready mix truck is going to go and deliver, and then finally it comes back to the plant, and it will be cleaned. The cleaning process is this one. J, once the cleaned water is again dumped here, and that is this water is again used as a recycled water. So ready mix J is nothing but ready mix truck with returned concrete, and K is recycled water, and L is reclaimed aggregate. Some this ready mix trucks, when it comes, when you clean it, it consists of even some aggregate particles and other things. So those particles are also recovered, okay, and that also will be making use in the next batch of this concrete. And M is your pump. M is your for this recycled water to pump it into the mixture. M is your pump, and N is water storage. N is water storage, and concrete loaded truck, ready mix truck, and that is nothing but this one, and it will go into the wherever site, construction site, it's going to go there and then return back. And the P is your control room. Okay, this is the overall picture about a ready mix plant, ready mix concrete plant. This is the various components in general, and this is nothing but your if the aggregate is coming from far places, it is shipped. That is the idea of having or shown here as a ship. Okay, any questions here? So let's move. So this is your transit mix truck. It's going to carry your concrete to the site from your mix plant. And once the concrete is delivered to the site, on the site you have all this reinforcement, everything placed, and the site is made such a way it is ready to for concreting. So this concrete, whatever is coming from the truck, it is going to be delivered to the particular location, and this is how it is going to be placed. And it's if required, vibrators will be used to vibrate this concrete. Okay. And here this picture is showing for something like a pavement or some slab. You can see here wire fabric or the wire mesh is there here, and concrete is getting poured. And this is mixing for small quantities of concrete. You can see this kind of concrete mixing thing on this side. Okay, this is for small batches of concrete, not for big works. So you are going to put in your cement, fine aggregate, coarse aggregate in the proportions that are going to be prescribed. I will show you in detail later. Okay, what should be the there are two types, whether you go by volume batching or weight batching. Volume batching means you need to put in certain volume of cement, certain volume of fine aggregate, certain volume of coarse aggregate, and then mix them, and then put the prescribed amount of quantity of water, and then this mixer is going to mix all of them together, and finally concrete is made, and it's going to be placed at the location where the intended location. Okay. Same thing even for this ready mix plant. Before we even put in all this material into this plant, we need to actually come up with the mix design. What should be the amount of cement, either in terms of weight or in terms of volume, how much amount of coarse aggregate, how much amount of fine aggregate, and how much amount of water. Water usually will be prescribed as a percentage of binding material. Usually it is mentioned as water cement ratio. Okay, and how to do this kind of a design in the sense, what should be the proportions of each of these materials for a particular grade of concrete, or for a particular targeted strength. What should be these quantities? That is what is actually mixed design. And IS yesterday or day before yesterday, I shared with you the codes IS 10262 that gives you the procedure for calculating each of these materials weights or volume. Usually, if you see, if you happen to visit any of these sites, usually these unskilled laborers, they like to have it in volume, because they can take a small like they can make a wooden bucket or something like that, and then once they put certain volume of that, or so many times of that bucket of aggregate, how many buckets of cement has to be mixed, and how many buckets of water has to be mixed. All this, it will be easy for them if it is volume batching. Okay, so we'll see in detail how to do that. And if you want, you can actually refer IS 10262. Latest version is 2009. Okay, and also I will explain you, and then we'll do one or two assignments on that. And now coming to so here I have compiled some material taken from different sources, whichever I feel is more easier to understand. So let's go through this. Concrete is most widely used material for construction. It consists of a binding medium of cement and water called cement paste, and particles of relatively inert filler called aggregate, and sometimes admixture. As I mentioned, admixtures are used to control the properties of hardened concrete as well as fresh concrete. Okay, the mixture, when placed in forms means in the particular location and allowed to cure, becomes hard like stone. The hardening is caused by chemical reaction between water and the cement, which continues for a long time, and consequently concrete grows stronger with age. And what is the strength of concrete at different days, or what, depending on its age, everything, code is giving some values. We'll see that. The popularity of the concrete is due to the fact that from common ingredients, it is possible to tailor the properties of concrete to meet the demands of any particular situation. Okay, concrete can be used or made from commonly available ingredients. The advances in concrete technology have paved the way to make the best use of locally available materials by judicious mix proportioning and proper workmanship, so as to produce concrete satisfying performance requirements. Okay, let me show you this. This is the code, concrete mix proportioning guidelines. Okay, and details of this code and other things you may be learning as a part of your concrete technology. But at this, as a part of this basic reinforced concrete design, at least you should know what is this concrete mix design and how it is actually carried out. Those, at least that much is required for this course. Okay, because concrete is the main ingredient for our course here. So IS 10262 2009 latest version, and you can we can go through this in detail later, but I want to just bring to your attention some illustrative examples are given in page 4 of this page, and page 4 and subsequent pages. Illustrative examples are given. Here, this example is given. You can read this one. An example illustrating the mixed proportion for a concrete of M40 grade. Usually, strength of concrete is indicated by this number 40. After 28 days, the concrete strength, the targeted strength is 40 MPa. 40, that number 40 stands for MPa. The letter M stands for mix. So M40 is the grade of concrete. So that is what needs to be designed. How it is designed, the procedure, everything is given. But we'll see some key points here. So the concrete M40, that is the concrete which is intended to have 40 MPa strength, compressive strength, 40 MPa at 28 days age. That is what is the targeted concrete that we want. And so that is what is noted here. Grade designation M40. What is the type of cement that is planned to use? That is ordinary Portland cement, OPC 43 grade. We'll see in detail what is this cement grade and other things later. Okay. And what is the size of the aggregate? And what is the minimum cement content? Where is this minimum cement content is coming from? That also we'll see later, depending on the kind of the exposure conditions. Because if you, depending on the location where this structure is going to be constructed, whether it is chemically this aggressive kind of environment, or whether it is close to the coast, all those things, depending on that, the minimum cement content is prescribed. And water cement ratio 0.45. Anyway, these are the inputs that are required for mixed design. And using this input, the procedure is given here. We'll go through this later. Okay. Just I am showing you, it is given in IS 10262. So once you have all this input, that means this is the input. Using this input, I need to design the concrete. So this using here for M20 grade of concrete, one example is given. And not only that, once you do all these calculations, you need to do trial mix, because you please see here, whatever the procedure that is adopted and other thing is assuming something. But when you actually take these proportions and mix it, and then you test those, once you mix, you're going to take some cubes out of it, and and those cubes will be tested. And how to do that, everything I will show you. We'll see more details later. And then once you do the testing, and if the strength that you get is less than 40 MPa or much more than 40 MPa, then you need to make some corrections, come back to this one, this trial mix again, or this procedure again, and then make the corrections, and then do one more trial. So this is an iterative process, or is a trial and error. So we need to do 2 or 3 times to arrive at the correct proportions, either by volume or in terms of weight. You can see here, mix calculations. After doing all the calculations, which we have not gone in detail, but we'll see later, the volume of concrete is 1 meter cube. For that volume of concrete, our targeted strength is M40, and then for that, for the given type of aggregates and other things, what is the volume of cement after calculation? This is the volume of cement. And what is the volume of water? This is the volume of water, 0.14 meter cube. And if you are using chemical admixtures, the volume of chemical admixtures is 0.006 meter cube. And volume of all the aggregates, that means coarse aggregate and fine aggregate. Coarse aggregate and fine aggregate put together, it is 0.743 meter cube. And then in this coarse aggregate, in this overall aggregate, what is the amount of coarse aggregate? What is the amount of fine aggregate? So that is calculated once you get volume of all the aggregate, 0.743 meter cube, from that mass of coarse aggregate, mass of fine aggregate. Finally, this is the prescription, mixed proportion for trial 1. I told you we need to do some trials. In the first trial, based on whatever calculations, these are the quantities that we will be using, and prepare a mix, okay? And then we will be doing the compression test on the hardened concrete, which is obtained by taking these proportions of materials, and then we will see whether the whatever targeted strength 40 MPa is achieved or not. If the 40 MPa, whatever strength we get is much more than 40 MPa or even much less than 40 MPa, we are going to do one more trial. So this is the procedure for mixed design. And here another illustrative example for same M40 grade of concrete, using, in addition to cement, fly ash is also used. So how to do the mixed design, that procedure is given here. Okay. So anyway, to quickly mention, this IS 10262 gives you the details of mixed design procedure. We'll see that later. Okay. So this is how the mixed design is carried out, and then that is fed into this. Whatever programmed into this ready mix computer system, and that will be used as an input, and based on that, it's going to do this controlling the weight of these aggregates, coarse aggregate, fine aggregate, cement, and water content. Finally, you will be getting the concrete of desired mix, whatever targeted strength, M40 or M25, whatever. Okay, now coming to this one, this is just now we went through this. This is something related to cement. And now let's go further. The finished product, hardened concrete, has high compressive strength, but its tensile strength is very low. What is that approximate value of tensile strength? It is approximately 1/10 of the compressive strength. This is approximate, okay? And if you go and see IS 456, let me go and show you IS 456. IS 456 gives you the tensile strength of the concrete, okay? The equation in the form of an equation, tensile strength of concrete. The flexural and splitting tensile strength shall be obtained as per IS 156. Anyway, we'll see in detail later. At least here, it gives you some value about the flexural strength. It gives you value about flexural strength. If you take a specimen and subject it to some flexure, okay, and you are going to develop some tensile stresses. That tensile strength, what is the tensile limiting tensile strength value? That that is given by this formula. Flexural strength is given by 0.7 root FCK Newton per mm square. Anyway, IS code is also giving you the formulas or the approximate estimations for this tensile strength. But in case if you don't immediately you don't have an equation, you can take it as 1/10 of the compressive strength. In situations where tensile stresses are developed, the concrete is strengthened by steel bars forming a composite construction called reinforced cement concrete. Okay, concrete without reinforcement is called plain concrete or simply concrete. Thus, a concrete making is not just a matter of mixing ingredients to produce a plastic mass, but good concrete has to satisfy the performance requirements in plastic or green state. Green state means when it is not hardened, when it is in fresh, when it is still you can mold it into the shapes that you want. Okay, so it has to satisfy performance requirements in plastic or green state and also in the hardened state. What is the performance requirement of concrete when it is in fresh state? When it is in fresh state, the concrete should have enough flowability. Flowability means when you place the concrete, it should on its own, without with the least effort, it should flow and occupy the entire space without any gaps or anything like that. I will show in a while a picture, a photograph where if that is not, if that requirement is not satisfied, what kind of thing is going to happen, I will show you in a while. Okay, so concrete should satisfy certain performance requirements in plastic or green state and also in the hardened state. In the hardened state, it should achieve the required strength. Okay, in the plastic state, concrete should be workable and free from segregation and bleeding. You please make a note of these two words or two terms, segregation and bleeding. Concrete should, when it is in fresh state, it should not have this kind of segregation or bleeding. What is this segregation? Segregation is nothing but what you did for this getting this concrete. You mixed coarse aggregate, fine aggregate, cement, and water, and these should not separate out. Before you place it and then it gets hardened, these should not separate out. Segregation is separation of coarse aggregate, and bleeding is separation of cement paste from the main mass. So these two things are not desirable, but we should know what these two things are. So segregation is separation of coarse aggregate, bleeding is separation of cement paste from main mass. In its hardened state, concrete should be strong. Anyway, that is what we desire, and it should be durable and impermeable. It should not have any cavities, or this cavity should not be linked together. Okay, and it should have minimum dimensional changes. So too much changes in the dimensions is not, because if we are casting a square like structural member having square or rectangle shape, that shape should not change too much. Okay, it should have minimum dimensional changes. In reinforced concrete, the concrete and steel components are to be so arranged and proportioned that optimal use of materials is involved. Okay, in order to obtain quality concrete for structural use, knowledge of concrete producing materials and their proportioning becomes essential. Okay, and in this lectures, we are going to briefly see concrete making materials like cement, aggregate, water, admixture, and the resulting product, which is nothing but concrete. Okay. In addition, types and properties of reinforcement and general overall of basic concrete structural systems. Any questions? Anyway, I'll give you some time, maybe 10 minutes at the end, then you can ask. So the first important ingredient in our concrete is cement, binding material. So in the mixed design IS 10262, when I showed you the illustrative example, we noted there is something like OPC, cement type is OPC 43 grade. What is this 43 grade of cement? So that we'll understand if you go through this. Cement, depending on the depending upon the intended use, cement can be of any of these forms: ordinary Portland cement, three types of grades, 33, 43, 53. If you go to your nearest cement shop or hardware shop where they are selling cement, you can when you ask any cement, they may be having cement of certain grades. They may say 33, 43 or 53 grade. Usually nowadays 33 grade is not available. 43 and 53 grades. What is actually this 43 grade cement? What is this 53 grade cement? That we will see. Okay. And other cement is rapid hardening Portland cement, Portland slag cement, Portland pozzolana cement, low heat Portland cement, sulfate resisting cement. Okay. However, the cement should comply with the requirement of relevant code. So for each of these types of cement, relevant IS code is there. The proportions are when you go to any cement plant, when they are manufacturing, not all cement plants will be manufacturing all kinds of cements which are listed here. Some cement plants may be manufacturing only certain types of cements. As I just mentioned, nowadays 33 grade, very limited cement plants are because the demand is less. They are not manufacturing 33 grade. Anyway, so depending on whichever cement plant is manufacturing whatever type of cement, they need to comply with relevant IS code, Indian Standard Code. Okay, so IS code is there for each of these types of cement: ordinary Portland cement, rapid hardening Portland cement, Portland slag cement, Portland pozzolana cement, low heat Portland cement, and sulfate resisting cement. This sulfate resisting cement is usually used depending on the environment in which the structure is going to be constructed. Okay, if it is chemically aggressive environment, then we need to go for these kind of special cements like sulfate resisting cement. Concrete mixes having high cement content give rise to increased shrinkage, creep, and cracking. So don't be a false impression. Don't be a false impression. If you put more cement, it is good. So please make a note of this. Concrete mixes having high cement content give rise to increased shrinkage, creep, and cracking. For high strength concrete, increase in cement content beyond certain value of order 550 kg per meter cube of cement may not increase the concrete strength. Okay, that also you can keep in mind. So if you keep on adding cement, that it's not going to result in high strength concrete. Okay, IS 3370 part 1 stipulates maximum limit of cement content to 530 kg per meter cube. 530 kg of cement per 1 meter cube of concrete. IS 3370 stipulates that is the maximum limit. Minimum cement content is going to be dependent on your durability considerations. Okay. As I mentioned, Portland cement is derived from its similarity to Portland stone, which was quarried on the Isle of Portland in Dorset, England. It was named by Joseph Aspdin, who obtained a patent for it in 1824. However, his son William Aspdin is regarded as inventor of modern Portland cement due to his developments in 1840s. Okay. Anyway, this is some story about this how this word Portland is appended to this cement. Okay. And now coming to 33, 43, 53 grade of cement, let's see what it is actually. Cement grade indicates the compressive strength of cement concrete after 28 days of setting. So what actually it means? 43 grade cement attains compressive strength of 43 MPa in 28 days of setting compared to 53 MPa attained by 53 grade of cement. So the grade of cement actually gives you, if you use higher grade of cement, you are going to get higher strength at an early age. And what is the actual difference between 33, 43, 53 grade? The fineness of cement is more in 43 grade. Fineness is more than 33 grade. 53 grade is more finer than 43 grade. As fineness, if you see, you go to your basic chemistry, as the size of the particles becomes smaller, its volume increases, total volume increases. So the more this water can actually cover each of these particles effectively, and chemical reaction is going to take place early. That is the reason how this early strength is obtained. So the difference between 33, 43, 53 grade is nothing but fineness of the cement. Okay. So we'll go through this later because time is running out. I want to show you a video, and before that, just to take a note of this this one, whatever is written about workability. Workability is the ability of fresh plastic concrete to fill the form or mold properly with the desired work in the sense vibration, and without reducing concrete's quality. So workability is nothing but the ease at which concrete goes and fills the entire mold or the form without any gaps or what is called honeycomb. What is honeycomb? I will show you in a picture. And whatever is left out here, okay, that we'll go through it once again in tomorrow's class. So let's see what happens if your concrete is not having enough workability. So this is what is going to happen if your concrete is not having enough workability. Please note that at the time of concreting, we will not be able to see this because your mold or formwork is going to be around, and here concrete is poured in, and the problem is whatever concrete that is adopted, that is not having enough workability. In the sense, it is not able to flow properly and fill all the gaps. So finally, once it is hardened, once the formwork is removed, this is what is the result of it. Okay, and you can see here another picture which is showing this is old concrete over which a new concrete is placed. Usually, when you want to place already hardened concrete, if you want to place new concrete, you need to do some kind of a special treatment before you proceed. I think here it is not done. On the top of it, even the new concrete, it's not compacted or vibrated properly, so that concrete fills everywhere. So that is the reason you have this kind of thing. In addition, you can see here some additional organic particles and also some additional foreign material which is not related to this work. Okay, so these kind of things, it shows the bad workmanship. And I told you this workability usually measured using the slump test. Okay, more details I will show you a video, then you will understand better. Just give me a minute. So we'll continue other things later in today's or next class, and let's see some videos so that helps you to have a better understanding. So this is hope you are able to see this one. Please note that whatever the schematic that I showed, it is whatever is being shown in this video, maybe slight difference may be there. Loading cement packs into cement transfer, the cement storage thing. And this is the computer controlled room. Cement pumping into silo. Cement silo. From the stockyard, the aggregate is being taken. Amlan, you are able to see now? Amlan?
Yes, I am able to see the full animation.
The video is coming properly?
Yes.
So aggregate is being loaded. And you can see both fine aggregate and coarse aggregate are put in. And how they are going to be mixed. It depends on the mix design. And this water, again weighing is based on the mix design. Mixed design is where you are required, and an engineer is required for giving the mixed design. And additives, this admixtures, if required. Admixtures are only if required. And mixing is happening. Everything. Aggregate, coarse aggregate, fine aggregate, cement, everything. And once the concrete is ready, it is loaded into the truck. And these kind of plants, you will be able to see where a lot of construction work is happening. All these multi-storied buildings, or wherever significant concrete is required, amount of concrete is required, they will be installing these things. Okay, and I will show you workability test.
The ease with which one can work with concrete is called workability. This can be measured using a simple test called the Slump Test. Let me show you the procedure. Slump cone test is a simple and popular test extensively used at sites to assess the workability of the concrete mix. The test should be conducted at the commencement of the concreting operations or whenever the workability of the concrete changes. The apparatus for conducting the slump test essentially consists of a metallic mold in the form of a frustum of a cone with a base plate to give you the edge. A steel tamping rod of 60 mm diameter and 60 cm height is used for conducting. The interior surface of the mold should be thoroughly cleaned of moisture and any hardened concrete before commencing the test. The mold is placed on a smooth...
Just 1 second, there is a disturbance, so I am going to start again.
The ease with which one can work with concrete is called workability. This can be measured using a simple test called the Slump Test. Let me show you the procedure. Slump cone test is a simple and popular test extensively used at sites to assess the workability of the concrete mix. The test should be conducted at the commencement of the concreting operations or whenever the workability of the concrete changes. The apparatus for conducting the slump test essentially consists of a metallic mold in the form of a frustum of a cone with a base plate. A steel tamping rod of 16 mm diameter and 60 cm height is to be used for compacting. The internal surface of the mold should be thoroughly cleaned of moisture and any hardened concrete before commencing the test. The mold is placed on a smooth, horizontal, rigid, and non-absorbent surface. It is then filled in 4 layers, with the thickness of each layer being approximately 1/4 of the height of the mold. Each layer should be tamped 25 times evenly using the rounded end of the tamping rod such that strokes are uniformly distributed over the cross-section. After the top layer is tamped, the concrete is leveled with a trowel so that the mold is filled exactly to the top. The mold is then removed by raising it gradually. The concrete will subside. This subsidence is known as slump. This operation shall be carried out without any jerks or vibrations and within a period of 2 minutes after completion of final tamping. The difference in level between the height of the mold and that of the highest point of the subsided concrete is measured. The subsidence measured is the slump of the concrete. The slump may either be a true slump, a shear slump, or a collapsible slump. The true slump is the desired form of slump that we require. In harsh mixes, the concrete slides down in an inclined plane. This is known as shear slump. In collapse slump, the concrete collapses as soon as the cone is removed. It usually occurs in very wet mixes. The concrete demonstrating a shear or collapse slump is considered unsatisfactory. In case of slump results beyond the specified limits, the mix proportion needs to be adjusted, especially the water content. The slump can also be varied by changing the proportion, size, and combination of the various sizes of the aggregates. It is advisable to assess the workability of concrete mix using a slump cone. Ensure that the cone is filled in a proper manner as indicated. Notice the type of slump. Shear and collapse slump are undesirable. Adjust the slump to the desired value by changing the proportion.
Okay, and
Okay, there was one question from a student that whether the water to cement ratio is by weight or by volume. That you can just quickly answer.
well, it depends. It depends on the cement. It is ratio, no? Whatever you are taking, same thing. If it is cement,
typically, I would say it is done based on weight.
yeah.
That means the weight of water to the weight of cement. That is called the water to cement ratio.
No. Yeah, that is also fine. But anyway, it's a ratio. So depending on whatever volume or weight you are taking cement, that ratio of water you are taking. Okay. And anyway, here some photographs of same slump test. And since time is running out, I'll quickly show you the codes before we stop for today. So this is IS code is giving some details. We'll see in detail later. But this is whatever slump cone test you have seen. The specification for that is given in this IS code 7320-1974. What should be the size of that frustum of the cone and other details, and what should be the tamping rod. You have seen what is tamping rod, what should be the dimension of tamping rod and other things. Okay, and this is about the apparatus for slump test and some other tests like in fresh concrete, how to do sampling. Suppose you have a big volume of concrete, what sample, where I have to take sample, how many samples I have to take, and how to analyze the concrete. All these details are given in IS 1199 1959 code. Okay, you can see here sampling of fresh concrete in the field, securing and preparing test specimen from hardened concrete, tests for workability. Whatever test, slump cone test we have seen, that is one type of test or one way of measuring the workability, and the other tests are also there depending on the type of the concrete. Suppose if you see the self-compacting concrete, there is a different type of test which is not necessarily this slump cone test. And also one more point I want to make here, it is mentioned in the video, there are two types of slump. How slump is going to happen, there are two types. One is shear slump, another is collapsible slump or collapse slump. And what is the shear slump? Shear slump, it is also mentioned in the video. If you see, it is mentioned, it is for harsh concrete. Harsh concrete is nothing but a concrete in which water content is less. And collapse slump is going to happen in a concrete which is actually having more water content. Okay. Anyway, both those things are not desirable. That is also what is mentioned in the video. Okay. Anyway, this gives you, this code gives you methods for sampling and analysis of concrete. And one more code, this gives you IS 516, gives you various methods for testing the hardened concrete. Hardened concrete, in the sense already the concrete is hardened. So in that case, what are the various tests that can be performed, and what are the things that we are going to get? And if you see here, contents quickly, test for compressive strength of concrete specimen, determination of compressive strength using portions of beam, making and curing flexural test specimens in the lab, test for flexural strength of molded flexural test specimen, determination of Young's modulus of elasticity by means of extensometer, determination of modulus of elasticity by electrodynamic method. So this code gives you various methods for tests on hardened concrete. Okay, so with this I'll stop, and 2 minutes. If you have any questions or comments, you please let me know. Amlan?
No, I would say it is fine. I had just seen only one question from their side, which I said. I don't think there was any other popped up question.
Okay, so they have a class at 9 o'clock. So if any further questions, just let me take attendance, and then we'll close this today's lecture. And one more thing is this there is a problem for me with this Google Meet. Can we have Microsoft Teams from next week? I request a class representative to take a survey, because to upload these videos and other things, there is a problem. Okay, so if you don't have any further questions, we'll stop here. Thank you very much. Okay, thank you. Attendance taken. Attendance taken.
Okay. Thank you, sir.
Thank you.